Hello and welcome. In today's video, we're diving deep into a fundamental building block of almost every PLC program, counters. We'll be using Siemens TIA Portal to explore the three standard IEC counters, and I'll show you a practical example of how and when to use each one. Let's start with a simple scenario. Imagine we have this door. When I press this switch, the door opens. Press it again and it closes. Our goal is to count how many times this door opens. After it is opened 5 times, we want to lock it to prevent it from opening again. This is a perfect job for a count up counter or CTU. Here in our programming environment, the only thing I've pre-configured is the HMI button linked to a tag. Our logic is simple. When the button is pressed, the door opens. Now, let's add our counter. In the instructions pane, under counter operations, you'll find 3 types. CTU, which is count up, CTD for count down, and CTUD for count up and down. We'll start with the CTU. Since this is a function block, it requires an instance data block. I'll name this one door_open_counter. Here's an important tip. Every time you use a new counter, make sure to create a new unique data block for it. If you copy and paste a counter but use the same data block, they will overwrite each other and your logic won't work as expected. Let's look at the counter block. We have 3 inputs and 2 outputs. The CU, or count up input, is the trigger. The counter increments by 1 on a rising edge at this input. This means it counts only when the signal goes from false to true, not continuously. We'll connect our door open status tag here. Next is the R, or reset input. This input resets the counter's current value back to 0. The PV, or preset value, is our target value. We'll set this to the number we want to count up to. I've prepared a tag for this and will set its start value to 5. The Q, or query output, turns true when the current value is greater than or equal to the preset value. And finally, the CV, or current value output, shows the current count of the counter. Let's download this to the PLC and see how it works. Notice the current value is 0. When I press the button, the door opens. The CU input receives a signal and the counter goes to 1. It only counts on that initial opening, not while the door stays open. 2, 3, 4. Now, watch the Q output. Our preset value is 5. When I open the door for the 5th time, the current value reaches 5 and the Q output turns on. It will stay on even if the count goes higher, because it triggers when the count is greater than or equal to the preset. Right now, the door can still be opened. To lock it, we'll use the Q output of our counter. I'll place a normally closed contact in the logic that opens the door and link it to the Q output. Now, when the Q output is true, this contact will open and the door will no longer receive the signal to open. One small adjustment. Because the Q output is true when the count is greater than or equal to our preset value, the door will only open 4 times if we set the preset to 5. To allow the door to open 5 full times, we need to set our preset value to 6. To make this functional, we need a way to reset the count. I'll add a reset button to our HMI and link it to the R input of our counter. Now, when I press reset, the counter goes back to 0. To make this even more dynamic, let's display the preset value and current value on the HMI. This allows us to change our target count without having to go back into the code. And there we have it. A fully functional counting and locking mechanism for our door. Complete with a dynamic interface. That's counting up. But what if you need to count down? Imagine taking items out of a full storage container. For that, we use a countdown counter, or CTD. I can simply change our existing block from a CTU to a CTD. Notice the inputs have changed slightly. We no longer have a reset input. Instead, we have LD, which stands for load. When this input is triggered, it takes the preset value and loads it into the current value. This is how we refill our storage. I'll connect our reset button to this input. The CD, or countdown input, subtracts 1 from the current value on each rising edge. For a CTD, the Q output turns true when the current value reaches 0 or less. Let's see it in action. First, I'll press our load button. Watch the current value. It jumps to our preset value of 6. Our storage is now full. Now, each time I open the door, it's like taking an item out. The count goes down 5, 4, 3, 2, 1, and when I press it one more time, the count hits 0. The Q output turns on, indicating our storage is empty and the door is locked. To start again, we simply load the preset value back in. Finally, what if you need to do both? For instance, tracking parts on a conveyor where some are added and some are removed. For this, we have the CTUD counter. This block is a combination of the first two. It has a CU input for counting up, a CD input for counting down, an R input to reset the count to 0, and an LD input to load the preset value. It also has 2 outputs, QU, which is the up output, and QD, the down output. I'll set up separate count up and count down buttons on the HMI to demonstrate. Now I can reset the counter to 0, count up to my preset value, and the QU output will turn on. Or I can load the preset value and count down to 0, and the QD output will turn on. It gives you the flexibility of both in one block. And that's a comprehensive look at the 3 standard IEC counters in TIA Portal. Use CTU for when you need to count up to a target value. Use CTD for when you need to count down from a starting value to 0. And use CTUD for when you need the flexibility of both. These are standardized IEC counters, so you'll find that they work very similarly in other PLC brands as well. While there are also legacy S7 counters available, I highly recommend sticking with these IEC counters for modern projects. If you found this video helpful, please leave a like and a comment, and don't forget to subscribe for more TIA Portal tutorials. Thanks for watching, and I'll see you in the next video.